Okay, hi guys. So in this lecture we'll be discussing about nomenclature of ketones. So let's get started. So nomenclature of ketones. I hope you remember the structure of ketone, that we can represent the structure of ketone as R C double bond O and R, where R is any um, any organic compound or carbon chain attached to the CO group on both the sides. Okay, so let's get started on the nomenclature of the above. So let's suppose we have this compound. So the name for this compound would be propanone. Okay, and why it would be propanone? As you can see, the longest carbon chain, it's still the third carbon, three carbon long, hence the name would be propanone. Let's see, for this case we have, so for this case the name would be again butane 2-one. And why? Let's do the numbering and see. So from which carbon we should start the numbering? From this carbon atom or from this carbon atom? Obviously from this carbon atom. Why? Because if you can see, we can find the functional group at second position here only from if we start the numbering from this carbon atom. But if we start the numbering from this carbon atom, we may find it at position number 1, 2 and 3. So that will not be the case, and we will start the numbering from this carbon atom, hence the name is derived. Let's see another example. We have something like this. So what would be the name of this compound? Again, the name would be, you can start numbering from any of the carbon atom, either from this or this, it doesn't matter, because from both the numbering standards we will find ketone group at position 2 and 3 only. So the name would be but 2,3 dione. Okay, let's see for this compound. So again, according to the priority rule, we'll be giving first priority to ketone functional group, then alkene functional group, hence the numbering would be from this carbon atom. So we can find at position number 2 only the double bond O group attached, and at 3 we can find the alkene group attached. So the IUPAC name would be, total number of carbon atoms in this compound is 5, so pent 3 in 2-one. Okay, let's see for this example where we have something like this. Again, the numbering won't be starting from this carbon atom, because the higher priority functional group is attached near to this extreme ended carbon atom rather than from this extreme ended carbon atom. Hence total number of carbon atoms here are 1, 2, 3, 4 and 5. So at position number 4 I can find a substituent, so the prefix would be 4-methyl, and then we can find the pent ring, or not ring, a pent chain, and then we can find 3 in and again 2-on. Okay, let's see for this compound. Here we have something like this and a substituent here. So again we'll be selecting the longest carbon chain. If we see this chain, we have 1, 2, 3 and 4 carbon atoms only, but if we see this chain, we have 1, 2, 3, 4, 5 and 6 carbon atoms again. So the longest carbon chain will be selected, which is of length 6, hence the name would be 3-methyl hexane 2-one. Okay, let's see for this. So what would be the name of this compound? So the name of this compound would be 3-methyl butane 2-one. Okay, let me correct my handwriting. 3-methyl butane 2-one. Okay, let's look at this example. We have something like this here. So the name of this compound would be, if we again we can recall that the numbering would be starting from this carbon atom, we can find ketone group attached at the second carbon atom alkene group at 3rd carbon atom and the substituent which is cyclopropyl at 4th position. So the prefix would be 4 cyclopropyl, then hex 3 2 on. Okay, let's see for this example where we have something like this. So for this, again, you can either start numbering from this carbon atom or from this carbon atom. Both will actually give you substituents or the keto group at 2 and 3 4 5 6. 2 and 6 position would have the keto group. Okay, so what would be the name of this compound? Again, word root would be hept. Why? Because 1 2 3 4 5 6 7 7 is the length of the longest carbon chain, so hept 2 and 6 dione. Okay, let's see the second last example for this lecture. And for the nomenclature of ketones, we have something like this, and this. Okay, so what would be the IUPAC name for this compound? Again, if you can just see that from this carbon atom we can actually find the substituents attached at if we actually go from any of the carbon chain, we can find the keto group attached at 2nd and 1 2 3 4 5th position. The functional group is attached, either we go from this side or from this side. So in this case, when there is a tie between the functional groups or the position of the functional groups, so the next priority would be on the substituent. The substituent is closer from this extreme end, hence the numbering would be done from this extreme end, and the methyl group would be assigned 3rd position. So why? Because 1 2 and 3. So the name would be 3-methyl, and what else? Total number of carbon atoms in this chain is what? 1 2 3 4 5 6 7. Okay, so hept 2 5 dione. Okay, so the last example for this video lecture, we have something like this. Okay, so what would be the IUPAC name for this compound? Again, whether it is alkyne or alkene, the numbering will not start from this carbon. Why? Because the higher priority functional group is attached on 3rd position if we start from this extreme end, hence the numbering would be done from this end, not from this end. Okay, so the total number of atoms, carbon atoms, or the longest chain in this case is 1 2 3 4 5 6 7 and 8. So total would be 8, so we'll write oct, and then we can find between ene and ine. I will be first writing ene substituent. Why? Because the first character E in ene comes before the first character Y of ine, hence alphabetical order is followed in writing ene and ine also. So 4 ene and 7 ine and 2 on. Okay, so with this we come to an end of this lecture. In the next lecture we will be seeing nomenclature of carboxylic acids. Till then, good luck and goodbye.